All right, so today we are going to discuss adding and subtracting rational expressions. So remember yesterday we talked about the fact that rational means fraction, and expressions are basically just anything that is a mathematical expression. So we have variables, we have numbers. So yeah, we're just adding these things, we're simplifying them, and we also have been working on stating restrictions. I know there's a little bit of a buzzing, sorry about that. But yeah, anything that's in the denominator that could make the denominator 0, we want to make sure we restrict that, okay? So we'll do a couple easier ones just to start here. What is the big thing I want to remember about adding and subtracting fractions? What do I need? Luke? Common denominator. Okay, so that includes both the numerical part and also the variable part as well. So each side kind of needs to have the same thing here. So between 3 and 6, what's my lowest common denominator here? 6, yep. So this side needs to become 6 on the bottom. I also need the variable to be present on each side. So this side needs a y, and this side also needs an x along with the 2 to make that 6xy. So I'm going to multiply that on bottom and also on top. All right, so we've got 4x squared plus y squared all over 6xy. That's our common denominator. Do a final check here. Make sure that you have canceled everything that can be canceled. I would always check the numerator and see if there's any common things that can be common factored. Between 4x squared and y squared, is there anything that can be common factored in the numerator? Faith? No, because it's a plus. So if it were a difference of squares, it has to be minus, right? But yes, if it were at 4x squared minus y squared, we could actually do difference of squares with that. Okay, can I do something like this? Can I reduce this x and one of these x's? Katie, why not?
Because it's an addition.
Yeah, there's an addition right next to it. So that is actually as far as I can go with this question. Can somebody help us with our restrictions for this one? Jameson?
X cannot equal 0 and y cannot equal 0.
Okay. So if either x or y are equal to 0, it's going to make this whole denominator 0. We also want to look, of course, at our original denominators. So if I have 6 times 0 or 3 times 0, those things will become divisions by 0, which we know are undefined. Okay, perfect. What I would usually suggest as well is when we're looking over at example 1b here, reduce first before you find a common denominator. You guys notice in this second fraction here, we can actually reduce something before we start finding common denominator. What can I reduce in this single fraction here? An x out of both of these, yep. So I actually have 5x over 6y minus 2x over 5. It makes our life a little bit easier finding the lowest common denominator, and we also won't have to common factor and reduce at the end. If you forget to do that, you're going to have to common factor and reduce at the end. It's still fine. Alex?
I just want to clarify that you can't reduce the 6 and 2 because they have different variables.
Not because they have different variables, but because there's a subtraction between here. I can only cross-reduce when I have multiplication between my fractions. Yep, good question. Okay, so what is my lowest common denominator? Between 6y and 5. Jameson? 30y, yes. So this side needs a 5 on top and bottom to get 30y, and this side needs a 6y. Okay, I'm just going to merge these into one fraction. Okay, and then usually to have this fully simplified and fully complete, we usually will see if there's any common factors up here. This is also just a good practice just in case we miss something along the way that could have been reduced. So do we have any common factors between 25x and negative 12xy? The x is common, so I can actually just remove that. And factored form is simplest form, so if you can get it into like a factored form like this or common factored, you should do that. Now I can't, this doesn't really help me reduce anything there, which is fine, so we'll just leave it there. Gibran?
At the beginning, so 12xy.
Yep.
There's a y there, and you need to have there's a y.
Right, but if I cancel this out, now I don't have a common denominator anymore to put these together.
Yeah.
So I don't really want to cancel out what I just done to find a common denominator, right? Okay, restriction, Myrna? Y cannot equal 0, yeah. Jack, question? I can. Does x have a restriction here?
Yes.
It does, because of this, right? So I also have to say that x cannot be 0. What, Jack? Can I what? Well, I have 2x squared divided by 5x, so I'm just reducing 1x out of each of those. Right. Stephen?
The reason why I can't get x can't equal 0 is because in the very top x is...
Because we have 5x, yeah. So any variable that was once in the denominator at one time, even if it's in the very first step, should be restricted in the final.
So
Stephen?
whether it's in the denominator, whether it's in the middle or at the end,
Yep.
just
Yep. Anytime you've had a variable in the denominator at any point, it should be restricted. Yep. Okay, any other questions? Evan?
For the first one, A, were there steps before you got to that one with the box in it, like 4x squared plus y squared?
I mean, I could write for you maybe the step before I combine them into one fraction. So I had like this, and then we just combine them into one fraction, if that helps. Anything else? Okay. Can I scroll? All right, so I've got some steps here for you guys for addition and subtraction. I've put them together because they're pretty much the same steps. I'm just going to wait till everybody's ready here. I've put them together as one set of steps because they're pretty much exactly the same, except there's one major difference between addition and subtraction, which I've put in bold here, and it's around step number 5. So we're going to kind of follow along with these steps as we do our questions below. But in general, we will start every multiplication, division, addition, and subtraction question by factoring and common factoring as much as possible on all numerators and all denominators. I will write restrictions just as I do for multiplication and division. But with addition and subtraction, I want to make sure I find a common denominator, which I don't have to do with multiplication and division. Then we'll put the fractions into one, kind of like we did above. So once we found our common denominator, we were able to merge the fractions into one single fraction. Now, when I'm working with more complex expressions, I will have to expand and simplify the numerator. The major difference is that if I'm subtracting, we'll keep the expansion of the fraction on the right side in brackets and actually distribute that subtraction into each term in that second bracket. You'll see what I mean once we do a question. Double check to see if your numerator can be factored anymore after you expand and simplify. And then you'll have two possible outcomes there. If I can't factor in step number 6, then I'm done. If I can factor, I will factor, and I'll see if any more canceling can be done. Okay? So there's a lot of steps here, but if you just kind of follow the process, you'll get the hang of it. Okay, so let's try a couple here. Start with this. Okay, first step, always factor and common factor everything that you possibly can. I usually like to, if I can't factor a common factor, I at least bracket up some of these binomials here so that I know that they're considered groupings. I can, however, factor this trinomial by finding two things that multiply to 8 and add to 6. Alex? 4 and 2 work. And this is trinomial factoring when a equals 1, so I can just put those right in brackets with their x's. Okay, so that's step number 1. We're going to write restrictions, so we'll start a little list at the bottom here. What are my restrictions?
-2
Alex.
and -4.
-2, and -4. That's right. Okay, remember the numerators don't need to be restricted. So x cannot equal -2 and -4. Now at this point, I also like to take a look and make sure that these individual fractions here, so not doing any cross-canceling or anything like that, but are there any numerators that can be canceled with any of their own denominators in the individual fractions themselves? Any groupings that are the same? Evan?
X minus 2 and x plus 2 are like have x in common.
Okay, so should I do this?
No, because there's addition.
Okay, can I cancel them?
No, because there's 1 minus 1.
Okay, so I don't think I can really do anything as far as canceling. If you can cancel at this step, you definitely want to. So I would actually even say, after you do those restrictions and before you find the common denominators, check to see if any reducing can be done in the individual fractions. This is going to make your life so much easier in some cases if you do this at the beginning. So we actually did it up here in this step. We checked to see if an individual fraction could be potentially reduced. So we're going to see if we're going to check to see if any reducing can be done. If so, then we will reduce in the individual fractions themselves. If not, we'll continue along with the steps. Okay, so next step is to find a common denominator. So in these cases, I like to just think of it as each side needs what the other side has. So right now they both have x plus 2's, but the fraction on the left is missing the x plus 4 that the fraction on the right has. Does that make sense? So this side needs the x plus 4. And I can't just put it into the denominator, I must also put it into the numerator. Okay, now do they have the same thing on the denominators? They do, yep. So we're going to merge this into one fraction. The fraction rule is that we keep the denominator and we add the numerators. So we're going to have x plus 4, x minus 2, plus x plus 10, all in one fraction now. Okay, can I cancel these x plus 4's now? I hear some no's and some yeses.
Yes. Yes.
This is a problem. Okay, so I know that this has a multiplication directly next to it, but in order for me to be able to cancel those x plus 4's, I need all multiplication to be happening between those brackets on the top. If I have this plus sign in between some of them, I'm still canceling individual pieces of this. So this is a big problem. I cannot cancel these x plus 4's at this point, okay? That is a big no-no. That's a big mistake that I see in this unit a lot, okay? So if you remember nothing from today, please remember that if you have an addition happening on the top that's separating out terms, you need to first expand and simplify the numerator and then get it fully factored. This is not fully factored at this point. Stephen?
You take the denominator of x plus 4 and x plus 2 off, that's how you get x plus 4x plus 4 also. Like,
Do I take it off?
Yeah.
What do you mean by that?
Where do you go? Like, how'd you get to that step?
You keep the denominator and you add the numerators. So like if I have 2 over 4 plus 1 over 4, what is this equal to? Right, so you're telling me you kept the denominator and you added the numerator, right? So you don't duplicate the denominator. It's just a single denominator now. Does that make sense? So I keep the denominator, I'm just adding the numerators together.
Take the one that you take out and you multiply it by the numerator and denominator on the
Multiply by the numerator and denominator on the
left.
left. Yes, so yeah, we need a common denominator. Yeah.
Okay.
Sorry, I don't think I answered your original question. Okay, so we're in one single fraction. We're going to expand the numerator and simplify. So I actually have to FOIL this out. This guy is really just a plus 1, so I'm just gonna put in a -1 there. I can really just drop the brackets on that because there's nothing really out front. Okay, so I'm just FOILing. I'm going to gather up some like terms here. So I've got 3 x's that need to be gathered, negative 2x, positive 4x, and positive 1x. That leaves me with plus 3x. And then negative 8 and plus 10 gives us plus 2. Okay, I do not need to FOIL the denominator here. Why do I not need to FOIL the denominator? Alex?
Because there's no addition until there's a specification.
It's already in like perfectly factored and simplified form, right? So there's no point in me foiling it back out because I'll just have to factor it again. So it's already perfectly factored. Okay, at this point, we're at step number 6 right now. We are checking to see if this numerator can be factored any further. So the question that you ask yourself once you have expanded and simplified the numerator is, can I factor this or can I common factor this at all? If your answer is yes, you will factor it, and then you'll see if you can cancel. If your answer is no at this point, then you're going to be finished. So can we factor this? Well, it looks like a trinomial, so are there any 2 things that multiply to 2 and add to 3? 2 and 1 actually work for this. So the answer here is yes, I can factor, and I will. So it'll be x plus 2, x plus 1. And you're just going to double check now that you've got this in factored form if anything further can be canceled. Now notice I have all multiplication happening on the top and all multiplication happening on the bottom. So are there any groups that can be canceled? Jameson?
X plus 2s.
The x plus 2's, yes, this is okay now that we have all multiplication happening. And I'm left with x plus 1 over x plus 4 with these restrictions. Awesome. Can somebody tell me about our restrictions? Which of these are vertical asymptotes and which of them are undefined points? Evan?
The negative 4 is a vertical asymptote and the negative 2.
Okay, the negative 4 produces on a graph a vertical asymptote where a graph kind of curves around. The negative 2 is just an undefined point. How did you decide between those, Evan?
Because like in the bottom answer, the negative 4 is what makes 0 a bottom.
Right. So I can actually see the restriction of negative 4 in my final answer. That produces a vertical asymptote. The negative 2 restriction got canceled out along the way, and all that produces is just a hollow undefined point. Good. Okay, I'll take you guys through a couple more just so you can get used to it, but most of this is just going to be you practicing and getting the hang of what you can do and what you cannot do. So let's move to the next one here. So first step, factor and common factor everything that you can. I'm looking for 2 things that multiply to negative 48 and add to 2 for that bottom left denominator there. Evan? Negative 6 and positive 8 works, yep. Great. And multiplies to negative 30, adds to negative 1. Gibran? 5 and negative 6, yes. Great. Check for your restrictions. Okay, we're going to start a little list just down at the bottom here for your restrictions. What needs to be in our list? Ansh? 6, yep. Jameson? Negative 5 is another one. Evan, give me the last.
So this is another one, but it should be negative 5 and positive 6.
Oh. Yes, you're right. Thank you. Let's do this. Yeah, sorry, I just mixed up the signs there. So minus 5 and positive 6. So that actually changes our restriction down here, right? Because it has to...
It's positive now, so.
Oh yeah, I was right. Sorry. Yeah, it adds to negative 1. So yeah, plus 5 and minus 6 is right. Natalie. Negative 8 is the last one, yeah. Sorry, threw me off there. Okay, so 6, negative 5, and negative 8 are our restrictions here. Before you continue and you find that common denominator, can I reduce anything in these individual fractions themselves? Are there any similar groups that can be canceled here? Not at this point, no. It's always a good check to do though, because we'll simplify our lives a little bit if we can. Okay, so each side needs what the other side has. What is the right side missing that the left side has? Myrna?
X minus,
Hmm?
never mind, I got confused.
Alex? Okay, so this side needs an x plus 5. The right side has one, the left side doesn't. Need that on top and bottom. What about the right side? What does it need that the left side has? An x plus 8. Okay. So each side needs what the other side has. That's the rule. Okay, now that we have a common denominator, I'm going to keep that denominator. And I'm going to kind of just merge the numerators together on top here. So they're being subtracted. Okay, we just completed step number 4 on this list. So keep the denominator, merge the numerators. We're now at step number 5, which is expand and simplify the numerators. So I'm actually going to FOIL these numerators. I'll need to do it on both sides here. And this is where the major difference between addition questions versus subtraction questions comes in. When I FOIL this, I'm going to actually keep it in brackets because the negative out front will have to be distributed into every term in my FOILed expression for that second part there. So I'll show you guys what I mean. For the first one, when I FOIL, I can just drop the brackets right away. So I'll do x times x, x times 9, 5 times x, and 5 times 9. But for the second part here, when I FOIL, I'm actually leaving this whole thing in brackets. So it'll be x times x, which gives me x squared, x times 8, negative 9 times x, and negative 9 times 8. And again, I'm leaving that in brackets because the negative term actually applies to everything in that second bracket that I've expanded there. Okay, so this actually needs to be brought in to each term in here. This is the one major difference between addition and subtraction. With addition, it doesn't matter because the plus sign isn't going to change anything in this second expansion over here. But the fact that I'm subtracting that whole second fraction means that I'm actually subtracting every term in this expansion. So you really need to be careful about that. Okay, I'm just going to gather up some of these things as I bring in this negative. So this is actually negative x here. I'm just going to put positive x. And then we'll take one more step just to simplify the like terms. Okay, so x squared and x squared actually cancel out here. And what do we get here? 117, I think. Thanks. Okay, no need to FOIL the denominator because it's already perfectly factored. Okay, now that we've expanded and simplified, we're actually on step 6. So step 6 says you need to ask yourself the question, can I factor or common factor the numerator at all? Seeing as this doesn't have an x squared term, I don't think I can factor, but is there a common factor between 15 and 117? Tej?
3.
3 is actually a common factor between these two values. So remember, factored form is simplest form. If I can factor, I will. So we're going to remove a 3. Divide that out from each term, and what is 117 divided by 3? Is it 39?
Yeah.
Great. Okay, and then the last question I want to ask myself is, can I cancel any further? Now that I have done that. So can I? What about this 6 and this 3? Why not? It's being subtracted, right? So I can't cancel individual pieces like that. So there's no more further canceling that can be done. So considering that, we are done our question here. Okay, so addition and subtraction is a little bit more of a lengthy process, but you guys still have all the skills that you need to do this. It's just a little bit more like foiling, and you have to double check if you can factor any more at the end. But you guys know how to foil, so you'll be fine. Any questions on this one? Okay, so what you might do is just put some stars around this step right here, because this is the key step that is different between addition and subtraction. This one is big. The fact that I have to FOIL in this negative into each term. Okay, this is the major difference between adding and subtracting. Everything else is exactly the same. This is the only extra thing I need to make sure I do with subtraction. Okay, can I scroll? All right, last one, and then you guys are going to do some practice. Okay, let's start by factoring and common factoring. What's 25x squared minus 36? Great, so this is actually a difference of squares, right? So I can factor that pretty quickly. Same thing with x squared plus 16. I can do x plus 4, x minus 4. Okay, here I'm doing trinomial factoring when a is not equal to 1. So I'm going to do it quickly over here. I trust that you guys know how to factor. So I think we should get 5x minus 6, x plus 1. And then over here, time multiplies to 3, adds to 4. That would be 3 and positive 1. Okay, if you guys want to know how I did this really quickly to factor this guy, watch the video. Okay, start your restriction list. I'm just going to do mine off to the side here before you cancel anything. X cannot equal. Jameson jumped the gun on that one. He already started canceling. Give me some restrictions here. Myrna. -1, yes. Not. Yep, go ahead. -3. What do I get from this? 5x minus 6. Evan? 6? Positive 6 over 5, yep. So I still switch the sign. If you're not sure how to get this, set 5x minus 6 equal to 0 and solve for the x that makes that happen. That's what we don't want to happen, right? So if I don't want that to equal 0, then I definitely don't want x to equal 6 over 5. Okay, so that is what our restriction, where our restriction comes from for that one. Okay, now Jameson, you said you started canceling something already at this point. What did you cancel?
The 5x minus 6.
Okay, so if you guys look in this individual fraction here, it actually has a common grouping in the numerator and in the denominator. This just simplifies so much for us. It's going to save you from having to deal with like weird trinomials. You guys don't even know how to factor, not weird trinomials, but weird cubics and stuff like that. You guys don't know how to factor those yet even. So cancel, if possible, if that's important that you do that. And this is what I'm left with here at this point.
Claire.
Okay, now it's also way easier to find a common denominator here because the left side is just missing something that the right side has. So what is the left side missing that the right side has in the denominator? X plus 3, yep. Okay, now we have our common denominator. We're going to merge together. Question, Alex?
Yeah, I thought you couldn't reduce them when you had subtraction.
If it's in the same fraction, then I can. See, this is all one fraction here.
Yeah.
So I can. I just can't do, like if I had an x plus, like let's say this was x plus 4, I can't do this across that subtraction symbol. But if it, as long as it's in one individual fraction, I can definitely reduce that fraction. Myrna?
No, it's just, do you put it now?
Yes, we're going to FOIL. So expand and simplify the numerator. Okay, this one, keep that in brackets. This one actually is just going to expand back into what we had originally, but it's going to expand back into this. But it still is important to do this factoring step just in case there's something that can be reduced in this fraction before you continue. So yeah, this is just going to actually expand back into x squared minus 16, but the negative does need to be distributed into that expansion. Okay, so here we get 5x plus 6x plus 15x, Alex, plus 18.
Sorry, can't you then reduce the x's plus 3?
Right here?
Yeah.
I can't do that because of this.
But it's in a separate equation there.
It's not, well, it's all one equation now. We've merged it all into one. Essentially, if I'm doing that, I'm just going back to what I had before. That's not really the point. We're trying to merge these fractions into one so we can actually like subtract them, right? So yeah, anytime, I really can't do this here because I'm canceling it out from one part but not the other part of this fraction since they're separated by a subtraction. I could FOIL the bottom, but it's already in perfect factored form, so there would be no point in me doing that. Okay, so here again, this is that major difference between addition and subtraction, and that is that the subtraction term needs to go into both terms that result from this expansion up here. Oh, and this is 5x squared, sorry. Okay, do I necessarily need to see every little like simplification step here? No, not really. It's more for you because if you're checking back over your work, it's nice to be able to see some of those steps. But I don't necessarily need to see them. Okay, I'm just gathering up some like terms here. What do we get there? 34? Okay, the last thing that we need to ask ourselves is, can I factor this trinomial or common factor anything from this? I don't think that there's a common factor. 2 isn't a common factor. 4 isn't a common factor. I would be looking for two things that potentially could multiply to positive 136 and add to 21. So what we could kind of check is like 20 and 1, 19 and 2, 18 and 3, and just kind of look at some of those combos there. Yeah, Luke? We're just almost done here. Can you wait like 2 minutes? Okay, so I would just check the combinations of things that add to 21 and see if they multiply to 136, because I feel like 136 is going to have quite a few factors. You could, 10 and 11 are probably the two closest things that add to 21. And if I do 10 times 11, I'm not getting close to 136. I'm just getting 110. You could try 12 and 9, but again, that's 108. So the two closest things, and that's going to give me the largest product that add to 21 are 10 and 11. And I'm not getting to 136 with that. 12 and 9 gives me 108. 13 and 8 gives me 104. 14 and 7 gives me 98. So the two things that give me the largest product aren't getting me to 136. So I actually can't factor this. So I'm actually done at this point. If I can't factor a common factor, that's finished. And we said above that x can't equal -3, -1, or 6/5. Stephen.
6/5, that was easier, right?
Yes, so that was from the bracket that we canceled here. Okay, can somebody tell me what the major difference is between when I add rational expressions and when I subtract them? What's the one thing that's different about this, Luke? I need a common denominator for both, so that's a similarity. Alex?
When you subtract, you have to apply the negative sign to everything inside of the expanded FOIL bracket.
In the second part, right? This is the major difference. I don't have to do that with addition. I mean, I kind of did it with addition here, but there's no point in me distributing a positive. That doesn't really make a difference. But there is a point in me distributing this negative, okay? So I've starred those special steps for you guys where there's a major difference between addition and subtraction. I need to make sure that negative gets FOILed into everything in the expansion on the second bracket there. That's important. Okay?